We're very excited to be hosting this session as part of our Roads to Research series here at Cohere for AI. The goal of this series is to demystify the machine learning research process and talk about all those things that go into being a researcher that are often kind of looked over. And so here we are today, and we'll be focusing on research ideation. This is the second session in our series. Our first one was some weeks ago. We hosted Sarah Hooker to talk about lessons to live by. I think the informal name for this talk was Living Your Best Life as an ML Researcher. And we've got a YouTube video, LinkedIn, and Twitter post where you can catch up on that if you missed this prior session. I'll put the links in the chat in just a moment. And the other thing of note is that if you're part of our open science research community, feel free to let us know that you've attended, share a key takeaway from the call, and those who attend 5 talks will get a new badge on Discord. Again, the link will come into the chat in just a moment. But now on to our main event. It's my pleasure to pass things off to my colleague Marzieh, who is hosting today's conversation, a panel discussion on research question ideation. So Marzieh, over to you.
Hi, everyone. Thanks for joining us today. I see a few familiar names and a lot of new ones. Happy to have you here with our great panelists today. Maybe we can start by introducing ourselves. So I'm Marzieh. I'm a research scientist at Cohere for AI, and today I'm here with Stella, Mustafa, and Eugene. So Stella is the executive director of Tutorial AI. Can you introduce yourself?
Sure. Hi, everyone. So I'm the executive director and longtime member of Eleuther AI. We are now a nonprofit research institute that focuses in large language models, but we've been around for about 4 years, primarily as a informal Discord community. We're still entirely organized online and have a very strong volunteer contribution to our research. A lot of the work that I have been doing of late has been kind of specifically on this topic, and so I'm really excited to talk about it. I spend a lot of time trying to bridge the gap between the open source software communities and the research communities, which oftentimes means helping people who have software development backgrounds or hacker type backgrounds, but less scientific experience, work on things like ideation, paper writing, etc. It's a topic that's very near and dear to my heart, and I've also been attempting to, success has been, follow through has been a little lacking, but I've been attempting to tweet one accessible research project in large language models or large scale AI research specifically that I think people I think would be valuable for people to work on. Yeah.
Yeah, that sounds great. And I think probably a lot of people have actually are familiar with your famous Twitter thread, and I look forward to hear how you come up with these ideas and where you find them. So next we have Mustafa. He's a research scientist at Google DeepMind. Take it away.
Hey, I'm Mustafa. I am currently working at Google DeepMind as a research scientist. I joined around more than 5 years ago. I joined Brain initially, and then it got merged to DeepMind. So kind of joined as a like a researcher for a team that the goal was bottom-up research, coming up with your problems, doing it, recruit people to join you, and solve a problem that is challenging. And then that was basically the initial idea and motivation of like the whole Brain team. And right now I'm working on Gemini, which is slightly different. So like changed gear toward something that is less on the bottom-up research and more on like the top-down system for doing research, but also pushing it to production or finding ways to make impact with research on production. My background, I did my PhD at the University of Amsterdam, same as Marzieh, and I had a lot of fun. And during my PhD, I did my PhD on language and like have background in language, NLP, information retrieval, and then after joining Google, just sitting next to vision people, I decided to explore the vision and multimodality. So it was just like not motivated by curiosity or interest. It was mostly like, my best friend or my best colleague sitting next to me was doing vision. I was like, okay, like I should do something with this this person. And now I'm mostly focusing on multimodal and trying to bring vision, images, audio, and videos to the language model, and basically make them as effective as they are on text and language.
Nice, thanks. And I love the bottom-up research idea analogy, and I think it would be nice to come back to it, maybe especially for new researchers, to share some insight there. And then lastly, we have Eugene. He's the CEO and co-founder of Recursal AI. Take it away.
Yeah, so I think for the larger context is I'm the co-founder of Recursal AI, and at the same time, I'm also the one representative in charge of the RWKV open source group. So essentially, the RWKV project, which actually came from what Eluta AI, essentially is a new architecture, sub-quadratic alternative architecture that is trying to tackle the quadratic cost problem in AI, and essentially be potentially 100x cheaper in terms of inference. That's on one thing, but on the second thing, it's also aiming to be the multilingual model in AI by being able to support over 100 languages. Collectively, under the Linux Foundation, right, our goal is to actually make AI accessible to everyone regardless of language or economical status. So that's the essence of the open source project. Because AI is just essentially the commercial entity that is backing this project, commercially speaking, and helping fund the project, essentially. So yeah.
Sounds great. Thanks. So let me start by Stella, asking you about what are in general your strategies to come up with your ideas for projects. So this can be from earlier in your career, but also from talking about experience right now.
This is a really great question, and it's one I kind of struggle with because I don't feel like I so much have a particular strategy. I think that in terms of how one should go about doing research, I think that a lot of people are spend an hour thinking. I spend an hour thinking about how I would answer this question, and I'm still struggling to do so, despite that. I think there's a pretty widespread perception that there are not very many distinct open problems in AI for people to work on. Everyone's working the same thing, that you need to be in a rush to solve, your particular problem before like someone else beats you to it. And descriptively, that is the case in many subfields, but there are a lot of other problems, and kind of, I guess, the main way that very few people are working on. If you go even a little bit outside the beaten path, there's a huge variety of very open problems. And I think the main way that I come up with research ideas is I read other people's papers and I ask, like, why am I unhappy about this paper? Like, what do I wish was different? Why is this? Oftentimes I have the experience of being excited about a paper and reading it and finding out that, like, the way that they did their experiments meant it wasn't useful to me. And whenever you have like an observation like that, you can ask yourself, well, why is that? Like, what is it that could have been done differently? And is that, and using that as a starting off point for research. This is something that me and my colleague Haley did a whole bunch last year. We were we were making a list of types of interpretability research for large language models that we wanted to do. And we very quickly realized that there was a whole class of problems where there was research that we'd like to be useful to what we were doing, but it wasn't, because what we wanted to do was understand kind of what the properties of a large language model are over the course of training, so that we could use that to kind of guide the development of better models. And there was this whole literature that was basically exclusively focused on analyzing fully trained checkpoints. And so now this is like an area that we've been working on for about 1.5 years now. It's been really fruitful, and just like taking a slightly different approach like that, like saying, well, maybe I care about how models actually like acquire, like where and when models acquire behaviors, as opposed to simply like how do they behave. Like that thought has led to like 5 papers over the past 1.5 years. And it kind of came out of this view of like, there's this research that we're really excited about, but it doesn't let us do the things we want to do. And so I think that can be a pretty useful framework. I think that another useful thing, especially for really junior people, is it's really easy to get caught in kind of the well-beaten paths of other people's research and what you're seeing at all the conferences. I really strongly recommend, like, to the best of your ability, setting some time aside to try to ignore that and ignore what people are working on and what other people think is interesting or worthwhile, and think about like what you are actually interested in and what you think would be kind of valuable on its own terms. It's very easy to convince yourself that you need to follow what other people have been doing because obviously it's valuable to do it this way because other people have been doing it. But a lot of the kind of research trends are kind of happenstance, or a famous researcher does something, and it's not that like it has to be done this one way or it's valuable because it's done this one way. It's just that there's a lot of follow the leader in the field, and that really setting aside time to think about like what questions are interesting to you and what kinds of lines of thought do you find yourself naturally attracted to is really valuable.
Yeah, I love that. There were a few points there that I really love setting time aside to ignore things. I think that was a very interesting point. But I think in general, that's a good point that a lot of times, especially as a new researcher, you might see a paper, not even read it, just like see the title and think a particular problem is solved. And like that's like I don't know. So I remember like my background is machine translation. I think in 2016 there was a paper that human parity with translation models have been achieved at Microsoft. But when you look at the details, you still think you realize what you mentioned about things that you are not happy with experiment setup with a lot of different parts of the project. So that's really a good starting point for finding your first research question to work on.
So that actually makes me think of something I want to jump on quickly, which is that oftentimes a paper is true, or the claims in a paper are true because of the specific framing of the paper. There are design choices or framework choices that are made by the researchers, and it's true in that framework. It's true under that experimental design. That doesn't necessarily mean it's true in other contexts. That doesn't necessarily mean it's true under other kind of experimental constraints. And there are very valid reasons why one researcher would care more about one experimental constraint and one researcher would care more about a different experimental constraint. And so taking problems and saying, this is true in the way that they framed it, but isn't true in this other context is a both very productive exercise to do in terms of critically thinking about papers, and also like another great way to come up with worthwhile ideas. So oftentimes translating project problems or experiments from one context to another is a really valuable way to produce high quality research.
Yeah, I agree. Thanks. Eugene, do you have any other strategies to come up with new ideas? So I know you mentioned about like your interest in like cheaper inference and efficiency of deployment, but in general, how do you come up with ideas of your projects?
So I think for us, right, for the group so we have two major things. But I think Firstly, for the group, when it comes to ideas, right, or no, more like for new researchers, right, we would really suggest trying to think beyond the mainstream path, and this is consistent with Stella's statement. But there is a very strong tendency for to view that there's only a very limited option when you actually kind of like view yourself within the bubble, for the lack of better words, and this bubble exists in multiple ways. So like for us, we are a sub-quadratic architecture. Alternatively, the bubble can be the transformer architecture. There are a lot of times when, let's say, when we suggest alternative to the transformer architecture, and then the bubble just basically says no. In other cases, right, let's just say put architecture aside, right, a struggle that Cohere and us share respectively is that sometimes the bubble could be just focusing on English and ignoring the multilingual problem. There is like so many things that is left untouched in the multilingual problem in particular. For example, we lack more than 30 evals in languages, and each language probably only has 1 or 2 eval. So when it comes to like even in the contest of like which is a better multilingual model, it's kind of like sometimes like, yay, we are better in this language in one test, and it doesn't really feel comprehensive itself. And these are some of the lower hanging fruits, right? That literally is just more of like, it requires someone to be a native speaker in that language to actually tackle that problem. To even like slightly more technical problems, like for example, like we have, I strongly feel like sampling and tokenizer, especially when it comes to like new sampling methods, and tokenizers when it comes to like multilingual tokenizers, is completely under research. We are just using the default in most research, respectively, and you can just like keep peeling the onion here at each layer, right? There's an angle where basically the entire industry is pretty much ignoring that there's work to be done there, and the way I view it is sometimes just take a step back and see the problem, right, for what it is for your larger goal. Some folks are trying to build AI to achieve AGI. Some people are trying to build AI to achieve a new frontier, or bring AI to the next level. And for the way I view it, right, is because we view AI as making it more accessible. The way we view it is not is we don't want it to be accessible only to the top 20% of the world. We want it to be accessible to the bottom 80% of the world, the rest of the world, basically. And the thing is like only 17% of the world speaks English. So that's where we started viewing it as like a problem that you want to run it on low-end hardware, you want to run it on multilingual, and then that's where you start noticing all these problems. And we don't have them solved. There's so many things that we have open-ended questions, and then you can just peel it into various stuff. Like other ideas one of the ideas that I'm pushing for, which as one of the alternative architecture, is I also want more research into text diffusion model, for example. And the reason why I say that is one of the big problems within LLMs is that we haven't really figured out why our models tend to overfit when we do just a few epoch. Well, the diffusion model teams are training at hundreds or even 1,000 epochs, repeating their data again and again, and somehow they are very resistant to overfitting. Why does that happen? We have absolutely no idea. Maybe it's something inherent to the architecture. The only way to find out is someone needs to train a text diffusion model and start this test. So think beyond the bubble and mainstream, and then you start to realize there's so much ideas that probably the same reason why Stella created a long list for people to work on is because you realize it's like, hey, there's more ideas than even my time to work on, respectively. And yeah, and sometimes it's more like a question of like which ideas to work on. So another thing that we do differently, because we are an open source foundation group first, right, is that when it comes to ideas, right, we actually do run a channel. I call it the RWK XDev, where essentially anyone in the community can post idea. And usually the biggest barrier is if you manage to just convert one of the training repos and add your ideas into it, let's say do your 10-line code change, chances are someone in the team will just pick it up and run it on one of our 3090s or 4090s to just test the idea. Because like sometimes it's sometimes the best idea actually just comes from anywhere, and sometimes the biggest hurdle is not always the idea, it's just converting that idea into code and then running it. And we recognize that actually a lot of people do have ideas, but they may not have the GPU resources to run the test runs. And that's kind of why we have always opened it up to the community, is anyone can submit their ideas, and if they can't run it, we'll run it for them. And if the loss curve and the evals show that the results are promising, that's how these ideas get merged into the next version of the RWKV architecture. And it's a very open format where essentially anyone can contribute, and that prevents us from being too siloed into particular train of thoughts, respectively. There were ideas that I actually personally disagree with, but then someone else went to run it, and it's like, oh, it actually worked. and then I myself find myself surprised and learning from it. Yeah. And forming new ideas.
Thanks. Yeah, I think there were a lot of good points there. So I loved how, Stella's point about maybe being critical and questioning the framework of each paper, and now you are adding to that, so being critical about the status quo of like accepted best practices of like the tokenizer, how we do decoding, maybe how even like the transformer architecture. So these are really valuable points. I did also really love, and I agree, the angle of multilinguality. So it adds a whole new dimension to everything that we've been doing. So if we look at language understanding and trying to, if we are trying to understand human language, then for each language, that adds a lot of point of contribution potentially. And data set creation, that was something that I think is very valuable, especially now with, I think still in English, we can also benefit from a lot of task evaluation sets, but also in languages, even more so. We also had the AYA project last year, which was targeting the multilingual language model problem. So very good and concrete places, I think, that you can make valuable impact, and really nice advice. I did also like your mention about the community and how to collaborate and in an open science community. I want to come back to that question later. But first, I want to ask Mustafa to see what are some of your strategies of coming up with ideas, and maybe you can talk about your bottom-up approach in general.
Yeah. So one thing that I kind of think about it in a way that, like at different stages of your life as a researcher, you have a different strategy for starting a new project or starting to work on a new idea, and sometimes it is motivated by just, oh, it's interesting, cool, and I just get a very unique satisfaction of working on it, which I think is like great. Sometimes it is motivated by the challenge, so you're looking for something that has a specific sort of challenge. It could be an unsolved problem, could be even like you're looking for something less challenging to take off and get familiar. So maybe you can start with something that like we call it incremental, and I think incremental should not carry any negative weight. I think it's like super valuable to do incremental research. And sometimes it is motivated by impact. If I choose this problem, what is the impact on other people's life? Like if I make inference faster, like Eugene is working, maybe this makes use of LLM more accessible to smaller entities, that they can run LLM cheaper, and then plug it into more applications and make it to get it to the hand of more people. or basically if I make like, you know, my LLM more multilingual, maybe someone, you know, like I'm from Middle East, and then every single time when I think about it, you know, someone in some village in like, you know, this country is looking for something, and if they can, like, you know, look it up in Farsi and then they get like great results. It's a huge impact, you know, like you're making impact on the life of many people, you know, like in this the next generation. So and last, sometimes you can consider a much bigger problem. I want to build an agent that does research, you know, and by research means it defines the problem, runs experiment, analyzes the results, think about, okay, what should I do next? You know, this failed, this one showed some sign of life, and then you break down this huge problem into parts, and then you start from like the existing things, like solution for different parts, and then if some part is not really mature enough for your huge goal, you start working on that. So in all these, you're mostly in charge of basically figuring out like what you can do and what you, like, you know, what is the so you should not start with something that is big, that you don't have the, like, you know, expertise immediately to get disappointed and then leave it out. But you should not also start always with something simple that is not like challenging for you to engage you for like a long time. Like one thing that I think like was kind of like interesting, like in bottom-up research areas or like in organizations, I think the challenge is sometimes like there are many things, you know, like, you know, at the end of the day, it's about like doing research, but also you need the reward part of it, you know, like you need success or you need something out of it, you know, like you want to see it making impact, right? So there's a trade-off. You cannot like constantly working on something that is challenging for a super long time, you know. Maybe you can, but sometimes, you know, like different dimension of life, like, you know, I don't know, like I need to basically defend my PhD thesis, or I need to, you know, like make sure that I have some artifact for my, you know, like next performance evaluation or something. So I think sometimes it goes down into like considering all these dimensions and then go with something that basically works best for this stage that we are at. And I myself really like the impact dimension of that. So this is the most like I get fuel from thinking about where this might go if I'm working on idea X. If I'm working on, you know, for example, text diffusion, I can think about that. Okay, you know, if I really solve this problem, or if I, you know, get like, you know, something in that direction working that might excite, like make other people excited about this, and then, you know, they jump on it and work on it, what happens, like, you know, next? And then and then the impact is something that kind of like gives me a score that should I work on it, or maybe I should work on something else, you know, like how many people are going to enjoy or benefit from this problem being solved, or like being in the next stage. But yeah, it's sometimes challenging. Sometimes we spend time on something that is much harder than we think, and sometimes, you know, the progress is not as we expect. But at the end of the day, if you make sure that there is a combination of all of these, you know, the coolness, interesting, you get satisfaction, it is impactful, it is challenging at the level that you need at this stage, and also it leads to something much bigger. I think that would be nice. But I think I want to a little bit of weight to what Stella says, like, you know, making sure that you're not like impacted by the hype too much. You know, that this is actually a really key point, and you should not ignore it, but you should not also, like, you know, just completely just, you know, condition on it based on the hype and, you know, what Twitter says I should like, you know, choose my my research topic. Yeah.
Yeah, I love that. So you have your internal reward model that you're training to tell you, like, give you a score of like what is a good research idea. And I think a point that you made really nicely is about working on maybe less challenging, more incremental and build your expertise in your research career. So not really trying to address like the big question, the biggest that you can in the first project, but really incrementally work on projects that can help you add to your expertise and your knowledge, and then you can get to the point that maybe you can make the bigger impact. I really like that. Yeah, nice. And your point about motivation, that's a very interesting point. That is not really about the topic necessarily, but just like thinking about the impact of everyone's, like the work that you do. I think that can be like very personal, and which is also like in research, that's actually a good thing to have a personal drive. So that's also a good reminder for everyone to think about that when they want to work on their research. I do want to say
I think this is what you meant, but it's important to disentangle impact from motivation. When in my experience, when people hear impact, they think like, you know, why do other people care about this, as opposed to why do I care about this?
Yeah.
Absolutely. Again, like these are like, you know, you could see them as orthogonal, you know, like things that we should optimize for, you know, like and yeah, like what if I enjoy working on a problem that that like no one else cares about, or like it's fine. Again, you know, I don't want to say like, you know, this is not good to do that. What we are just this is just a choice that, okay, I want to put more weight into this dimension than the other one. But I think like, you know, having a trade-off or moving, you know, like in these ways, you know, like I want to start from something that no one cares, but I enjoy it. And then at some point I want to move to other one. And you can even always just, you know, move around like in this problem space to find something that you need at the time. And yeah.
Mm-hmm. So I'll point out that I completely agree with Stella said, and amusingly, because we are more like on the open source code side of thing rather than the paper writing. We are so bad at writing papers. Eluta AI help us write the paper for us essentially. And the funny thing about our group is it's more motivation driven than impact driven. To a large extent. If anything, one of my biggest role is actually organizing everyone's motivation towards common impacts. Because everyone there's a tendency, especially for a large open source project, because since everyone's essentially volunteers, to be like, hey, I want to work on this because I want this for myself. And that's what keep like most of the motivation going. Like the reason why we have let's say RWKV CPP, which allows us to run our model even on a Raspberry Pi, was because someone really wanted to run it on the Raspberry Pi. That was it. It wasn't really about impact. It wasn't about it wasn't about like writing a new paper or making anything groundbreaking, because we already had Llama CPP actually. And it was just more of like trying to get the best performance on a really low-end hardware, and it was just for fun in that sense. So a lot of there is a lot that can be made just through motivation. Because sometimes like I said, the biggest hurdle for ideas, right, even within our group, despite all of that, right, has always been the conversion from ideas to code. Because that part is always the biggest hurdle. And then after that, from code to results.
Yeah, good point. Thanks. So I do want to mention, if anyone in the audience have questions, feel free to leave them in the comment section. And I have a question for the group. So whoever wants to go first. We talked about the positive side of coming up with ideas, what to do, but also what can you share about common maybe pitfalls and mistakes in building your research question that maybe you personally have experienced, or things that you think researchers should be avoiding or like pay attention to when they are trying to come up with their research idea?
I think be very aware about your resource constraint. That is, there's no way beating around it. That is a challenge. Like like these days, my number one role is more of like I jokingly say GPU finder for the rest of the group. And essentially your resource will dictate what kind of problem can you tackle. So that's kind of why I laid out my open-ended problems, right? From essentially least compute required to most compute required. Because like ideas such as data set or even requires a essentially near zero training compute that's required. Ideas like sampling, you do require some compute to like do large scale evals essentially to test these ideas. Tokenizers and architecture changes, you need to train a new model, and no way beating around it. You need GPUs. Understanding resources, because depending on your organization, as much as you we just said, like, try to look outside the mainstream. One of the biggest challenges is most of the resources are going to mainstream research. So it is a certain art and a skill to like do something that is not mainstream, but yet initially presenting it and packaging as something mainstream so that you get the resource grant that you want, and then basically essentially you do the best of both worlds.
Yeah, that's a good point. So there should be enough number of people who care about this. So maybe not the most mainstream and hype idea, but still some people should care about this so that you can. And I agree with the resources, and just also like thinking about just the cycle of experiments of your idea. Like if it's, for instance, at the pre-training phase, and you have for each experiment you have to run like a full pre-training that takes like 1 week or 2 weeks. That's really different than an idea that the cycle of experiments is maybe 1 hour. So the way that you can, like, resources, both compute but also time, I think is very, very important. Yeah.
I can go next. So I actually have a really long list, but I want to just talk about the two of them because I felt like these two are kind of like somehow I felt these are the most important things that I've seen. Some of them I made these mistakes, and some it's just like I've seen like colleagues or friends or other researchers actually making this. So I think like one thing is to be like one of the biggest issues that we're seeing these days is like being extremely opinionated, and I think a good researcher always gives a good possibility to being wrong in many situations. And we've seen that many like researchers that like they are like leaders of the field, like as we refer to them, they make mistakes, like they insisted on something and then they were proven wrong, like couple years later or something. And I think if someone always, like a good researcher, always think about even if I like truly believe in this idea, I need to give at least a teeny tiny possibility that I'm wrong. And what this not only helps you to be a better person, like being humble, respect other people and different ideas, but also it helps you to think a bit more thoroughly about how to fix the issues. If you always focus on something that and you just truly believe that, okay, this is the absolute and the only way to do it, you may get into a situation that you just reject all the other ideas that could be as good or even better. So and it's easy to get to that state. I know that in my life I got to the situation that this is the only way to do that, and everything else is just wrong. I even remember one funny discussion that I had like with Marzieh, like maybe 6-7 years ago. We're talking about PyTorch or Theano versus TensorFlow, and at that time I was like, TensorFlow is like this. Look at this, and right now if someone asked me like I think like TensorFlow was something that we had to move on. I mean right now we're using JAX, but like being opinionated about a framework kind of like maybe even slowed me down for some time. I just talk about like something like simple, but like there are many things that we're seeing at least within company. I can see that we are spending a lot of time just fixing the issue with some group or someone being opinionated about like a wrong idea. The other one is also developing the skill. So it's not a mistake, but this is something that we should learn how to fix an issue. But developing the skill of moving on. So like learning how to and when to move on is a really hard thing. Like sometimes you spend like weeks or months or years working on an idea, and then sometimes it just becomes a sunk cost fallacy, and then it's really hard to move on. And if we manage to think about, okay, what is the time to move on, and like how can I it's fine if I spend a ton of time and an effort on it, but like it's time to move on. It doesn't work. Or sometimes if you move on like a bit too early, you just give up something that might work with a little bit more push. So it's really hard. I struggle with it right now. That okay, should I still keep working on it? Should I keep everyone excited to working on it, or no? Like there's an idea B which might be easier or better. So that's also something that like if you don't have the skill to know when to move on, you might like waste a lot of time, or you might just get into a lot of suboptimal solutions or ways of doing research. And I think that's also something that I noted as the issue, not like that I have, and I think it's really hard to fix it as a researcher.
Yeah, I think those are really great points. And I do have to add that you've always been very passionate about what you're working on, and I love that about you. But this is also like a really good reminder that maybe everyone has to have like me included. I think I was also wrong with universal transformer, if you remember. So there are a lot of parts that we all should be having our critical glasses whenever we look at research, whether it's our own or someone else's, in a positive way. So not really trying to necessarily find things that are not really there that are wrong, but really trying to be looking at what can be better, maybe. That would be, and I love your advice about learning to move on. Like that's really, we get attached to our ideas and our projects, and it's important to know when is the time that maybe we have to move on. So that's also something that I think personally, it just comes from doing it a few times. I don't know if you guys have any advice about like when to identify, like when is the time to quit a project or an idea, or pivot maybe to something else. I'd love to hear if you have any ideas.
I mean, I don't think that's a question that has a universal answer, right? Like, I think that, yeah, so I guess I'm kind of curious, like, what would you be looking for in an answer to that question?
Well, the obvious one would be like if someone does exactly that, right? But like if you get scooped, but yeah, I don't know. Like if there is the diminishing return point, I guess, when you think you are trying maybe too much and too many failures. But I do agree that it's not really a like one universal answer to that.
I think the best thing that you can do is if you're trying to figure out whether you're, too invested in something and it's not panning out and you should just move on, is to get an outside opinion. I think almost by definition, when you're in such a mindset, you're very attached to the problem, you're very or to the approach that you're working on, and it can be really challenging to be critical and objective about the progress that you're making and about kind of what counterfactually you could have been working on instead. So I generally try to ask someone else that question.
Yeah, I love that. Some fresh perspective into the project. Nice. So there are some questions in the chat. I do want to maybe have one question for the panel about communicating research ideas. So I think coming up with the idea is a big part and really important, but also how do you communicate that to your collaborators? And then once you work on this project, share it with the world. So what are some key points that maybe you can share about, because I feel like it goes hand in hand with also how to come up with the idea. So it's really important to know how to also communicate that.
I can again go first and then quickly talk about, like, what is the okay. So one thing that I notice is that in many situations, what works is if the person has a good idea, because like, again, I like, it's great to have ideas, but also like many people have a lot of ideas. So like, if we sit in a room and then talk about ideas, like, for months, we can just, gather idea. But like, I think the main part is how to get that idea to reality. And in many situations, like, people get on board or they get impressed or they like start believing in an idea if there's a sign that this idea is good and working. And I know that this is maybe not the best, like, this is not like, the most optimal situation, but in most situations, what happens is that the person with that idea has to go for the first iteration, implement that, and show that, okay, this is working to this capacity, to this extent, and then present it to others. And then when they see that, okay, like, there's a few steps already taken toward, like, this goal, and then they might just get excited. But like, just talking about it is sometimes hard, and I think, like, if someone has ideas, I think probably they should just get their hand wet, and then like, just work on it, and then push it for a few steps, and then show that, okay, there's some sign of life. And I think that's probably the most feasible way of showing an idea is good, or like, getting people on board with like working on this idea. And like, related to this, I want to say that basically this means that if you are a researcher, you have to be skilled in terms of engineering and like, ability to implement something really quickly. And the main reason for that is that if you want to work on an idea, you can really quickly, if you are skilled with the engineering part of your like, research, you can implement things, like, try them fast, iterate over them fast, and then also present them quick enough to other people. And like, this kind of emphasizes the requirement for developing engineering skills as a researcher, and coding, and like, instead of depending on always on other people, or being really slow in trying out something like really quickly.
Building off of that, one very common conversation I have is people ask me, what do I think about X idea? Or do I think Y is the case? And very often the answer is, I don't know. That sounds like an empirical question. Like, we should, like, run some experiments and let's find out. And very rarely is the net result of that conversation someone actually going and running experiments. People are, I very regularly get pushed back. Well, if you had to guess, I'm like, I don't want to guess. I don't know. Like, this is a empirical question about behavior of models, and I don't know what the answer is because I've never seen any evidence in any direction. And sometimes I follow up with people who I have these conversations with, like, a week later, and it's very rare that people will have actually run the experiments to go find out. Sometimes they decide what they think the answer should be. Sometimes they get busy, get focused on something else. Sometimes they just go, oh well. But being able to test your ideas quickly and effectively, especially the really, really basic ones, for science of life, as was said, is extremely valuable and extremely rare.
Yeah, I think I'll like, since topic of like research ideas also, right? especially when it comes to foundation model, right? I'd like to emphasize that ideas doesn't necessarily means you need to run a large model, 7B, 3 billion, as your first test. Most ideas we run the first test is at a 0.1 B, like basically mini models 0.4 B, and you'll be surprised at the bigger bar to clear, right? It's like, idea to code and then code to results, right? The first bar to clear is to not make the model drastically worse, because it's very easy to make the model drastically worse, and sometimes we get too caught up on what is the final answer, when sometimes it's just, like you say, just testing it instead of like jumping to the conclusion and then getting the empirical results respectively. And what's the smallest and fastest way to test it is something that you need to decide within your problem space or your group space respectively.
Mm-hmm. Yeah, really good points. Thanks, everyone. So I want to go through the chat. There are some questions there, and maybe I'll point to one person per question, but feel free to jump in. So the first question is from Inomer. Maybe Stella, you can take this. They're asking how much should we think about viability or in real life usage while formulating ideas to research upon? Like, for example, if someone is interested in quantum machine learning, but at its current stage, most of it is based on simulations and not actually implementable for direct use. So do we account for such impacts while ideating, or is it just too far down the line for a foundational ideation stage?
I think that depends a lot on what you want to accomplish. I mean, I would describe all quantum algorithm work as pretty speculative at best at this point, given that it's unclear whether we have working quantum computers in the first place. But if there are, it is absolutely reasonable to do highly speculative work that you don't know if it's going to kind of correspond to something that impacts somebody's life in a meaningful way in the next decade. It is also absolutely reasonable to look at a problem that's shaped like that and say, that's not what I want to be working on. I think that this is I think that this is a personal prioritization question more than there is a correct answer. And absolutely, it's valuable to have people doing far future oriented research. It would be pretty bad if nobody was doing that, because one day it's not going to be far future, it's going to be medium future, and then one day it's going to be near future. And it would be really good to know things about it, at least preliminarily, or have a direction to head in ahead of time. So I wouldn't let that discourage you, but I would also be kind of realistic about, when you're talking to yourself about what are the goals that you're trying to accomplish. If you want to do something that's going to impact the lives of people using models, then you probably shouldn't be doing quantum machine learning research. But it's perfectly reasonable and to not prioritize that. And I also think it's good that some people don't.
Yeah, thanks. Next question is for Eugene. Pulkit Madan is asking, you mentioned that some of the biggest hurdles are ideation to code and then code to impact. What are some approaches that you have observed to help in both of the scenarios?
So for ideation to code and code to impact, I think this is more the process that we currently settle on, right? Is kind of like incidentally helping like common issues that we face in all this pipeline respectively. So the big issues that the community face, right, is one is two big ones. One is the ability to or the skill set to implement the idea into code. And two, essentially is the ability to run it on GPU resources, because not everyone in our community has 3090s or etc. and above. And essentially by putting it into a public board, right, and where people can either contribute idea, or people can help implement the idea, or people can help run the idea. So these are the three major distinctive steps, and they're not mutually exclusive. In some cases, someone can be running an idea that they weren't involved in the first two, or vice versa. It helped create a pipeline where essentially it's just more of like winning support at each stage. So so like I mentioned, I alluded to, there were ideas that were ran that surprised me that I didn't agree at the first stage. And that is awesome, because that is that will be by design, that there'll be multiple folks at the first stage where they are willing to bring the idea forward. Because then essentially, if your idea makes sense, it makes logical sense that someone can implement it, then sometimes it just might be just worth running at a small scale. And sometimes I may have missed the point, and that's fine. Because everyone has their own train of thought that will miss the point respectively. But if someone else believes in you, and then they can help you assist there. And in some cases, if for some of the most senior members in the group, they already know how to write their own code. Heck, sometimes one of the problems that we face is that everyone is writing their own trainer. Essentially, we have more trainers than we like to maintain, and then they're just wanting GPU resource, and that's more straightforward. It's just more of like, okay, what's the idea here, and how long do you need to run it, and then okay, who has the resource? Okay, let's allocate accordingly. So it's just keeping that flow running, because ideas drop off, be it by a personal motivation level, or be it just bad results. So like we run tests at 0.1b, 0.4b, and then 1.5b, and that's where it becomes usually a candidate to join the main models. And at every stage of the process, we come to the realization, hey, this doesn't scale well, or this doesn't perform well, and that's it. So it's like all those, it needs to go through all the steps essentially, and just to run with it, just to streamline it.
Thanks. There are some questions in the chat. We are at the time, so I already see some people are answering each other's questions, so that's great. I do want to ask each of you maybe very quickly one takeaway that you want to give our audience. So what would be maybe one advice or one general direction that you want to share? Who wants to go first?
In general, the field of AI is wide open. There are tons of important and valuable and accessible questions that nobody is working on. There are ideas that I have come up with or thought about and considered tackling that went unstudied for over a year, despite me promoting them and asking people to go work on them. It can seem on a local level that everyone, that everything is a rush and that everyone is working on the same problems. And that is because everyone's working on the same problems, but that doesn't mean those are the only problems.
Nice, thanks. Mustafa, you want to go next? Oh, you're muted.
This is maybe a bit different from what I expected to say, but I just wanted to say that one thing that I noticed is that like the best part of research is finding ways to work with other people, and like take any opportunity to find good people and work with them, and this maximizes the learning experience and also fixes you from like it just prevents, like basically there's a mechanism when you're working with the smart people and good and experienced people that just like doesn't let you to go to a situation where like why you're just like overfitting to something that is not like the best solution, but also it's just like pure joy to work with good people, and like this is not maybe like about research, is like in general find people that you should work with them or be friend with them. But in research I find it like specifically really good to work with a group of people that they're good researchers, and like no matter what is the outcome, it's just like you never feel that it was a waste of time. Like like no matter if the project fails or whatever, it's just like really good to work with smart people and learn.
Yeah, thanks. Eugene?
Looking at some of the questions, be very open, and this part is a double-edged sword. Consider tackling more than one problem at a time. This might end up spreading you too thin, but it prevents you from being too over-invested into one absolute idea. And it makes it more acceptable when ideas fail, because ideas by definition will fail along the way, and that allows you to really just keep going, because personal motivation is also another thing. It's probably going to be the bigger barrier than almost nearly every other barrier out there, and so like Stella and I may have our own long laundry list of like, if you want an idea, here's some ideas that you can work on, but at the end of the day, it's what motivates you. So, and our list might not motivate you, because what you want to do personally is really up to you.
Yeah, thanks. Well put. And I feel like we can talk another hour just about this. We barely touched the surface, but we are unfortunately at the time. Thanks a lot to all of our panelists, and I'll hand it over to Madeline.
Yes, thank you. Wow, what gold shared today. Thank you so much, Stella, Eugene, Mustafa, and Marzieh for hosting. Thanks to everyone who shared questions in the chat and everyone who was able to make it out today. We'll share a recording of this session soon, but just flagging some links I shared in the chat. Share a key takeaway. We'll be using these to share out to everyone and gather our collective learnings. I've just put the link to the form in the chat. And otherwise, we've got upcoming sessions on applying to research roles, both in industry and PhDs and academia. And then we'll also have some more interactive sessions coming up, including stories from the road and some interactive calls. So we hope to see you at future sessions. But otherwise, thanks again for coming out, and we'll look forward to connecting with you in other ways. Have a good day, everyone.